Okay, so in this video, Introduction to Physics, we'll be looking at relative density. Uh, this is an introductory video, right? I'm your host, Junior Roberts, with RealJuniorRoberts.com. So let's begin. Okay, so first of all, let's discuss the objectives of this lesson. Our first objective is for you to, at the end of this lesson, be able to define the term relative density, to recall that relative density is a dimensionless quantity and it has no units, and also to be able to use the formula for relative density to perform calculations. So our first thing that we look at is to find out what exactly is relative density. So in order for us to get an appreciation for the term relative density, we first need to recall what is meant by density of an object. So in our previous video, when we talked about density, we said that density is actually defined as the mass per unit volume of an object, right? So it's basically how much mass is contained in a certain volume of that object. So whenever we use the word relative in physics, typically we are comparing the properties of two different substances or two different objects. So therefore we can consider the relative density of an object as how much denser or how less dense that object is when compared to some standard. And for our purposes, we use water as the standard defining relative density. So the density of water is conveniently 1000 kilograms per meter cube, or 1 gram per centimeter cube, which makes it extremely convenient to use this density of water as our standard. So we can say that the relative density of a substance is the ratio of the density of that substance to the density of water. And we can actually develop an equation for relative density where we say that relative density is equal to the density of the substance divided by the density of water. So okay, so let's talk about the unit of relative density. So the relative density of a substance, again, is a ratio where we're actually comparing the density of the substance to the density of water, right? So we can write our formula again where we say that relative density is equal to the density of substance over the density of water, right? And in terms of their units, we can write out their units. The density of the substance will be in kilograms per meter cube or in grams per centimeter cube. And as you can see, if we have the units like this, we will see where the units will actually cancel, right? Because we have kilograms per meter cube dividing kilograms per meter cube, so therefore they will cancel, leaving us with no units, right? So let's talk more about the unit of relative density. So relative density is a dimensionless quantity, right? And this means that it has no units. So whenever we're writing the relative density of a substance, we can simply write it as a number with no units. So for example, let us say we want to find the relative density of copper, and we are given that the density of copper is 8.96 grams per centimeter cube. Our first thing we'll do is actually write out our formula where we say that relative density of copper is equal to the density of copper divided by the density of water. So we can go further to fill in our values. So the density of copper is 8.96 as was given before, and the density grams per centimeters cube, and the density of water is 1 grams per centimeters cube. So when we do our division, we see that our relative density is equal to 8.96, and again no units. So this is telling us that copper is 8.96 times more dense than water. Okay, so a quick activity for you to do, right? So you can choose to pause the video and solve this on your own and then check back with the answer. Okay, so we want to find the relative density of aluminum, and we're given that the density of aluminum is actually 2.9 grams per centimeters cube. So the first thing we'll do is we'll write our formula. So we'll say relative density is equal to the density, in this case of aluminum, divided by the density of water. Right? So we know that the density of aluminum is 2.7 grams per centimeters cube, and the density of water is 1 grams per centimeters cube. Right? So we're given our density of aluminum in grams per centimeters cube, so we can write the density of water in grams per centimeters cube. So when we divide these, we'll get that the density of aluminum is 2.7, and again we have no units. Right? So our next question is to find the relative density of a piece of metal that has a density of 11.3 grams per centimeters cube. So we'll start by saying that the relative density is equal to the density of substance divided by density of water. So in this case, our substance is a piece of metal and it has density of 11.3 grams per centimeters cube. So we'll say 11.3 grams per centimeters cube divided by the density of water, again, is 1 gram per centimeters cube. So when we divide these, we get that our relative density is 11.3. Right, so the relative density will be 11.3, and again, because we're talking about relative density, we'll have no units. So our final question asks us to find the relative density of a block of metal that has a dimensions of 3 centimeters by 2 centimeters by 4 centimeters. So let me just do a quick sketch of this block here. So let's say this is our block. So a block of metal. Alright, just a quick sketch. Alright, so this is our block of metal, and we're told that the dimensions are 3 centimeters by 2 centimeters by 4 centimeters. So to find relative density, again, we'll say that relative density, I'm going to write it as relative density is equal to the density of substance over the density of water. But as it is right now, we don't know the density of our substance, so we first need to find the density of this substance. So density is equal to mass divided by volume, right? But in our question, we're only given the mass, and we're given that the object has this dimension. So we first need to find the volume of this object, so we can actually use our formula to find density. So we say that volume of a cuboid is actually length times width times height. So length is 4 centimeters, so we say 4 centimeters times the width, which is 3 centimeters, times the vertical height, which is 2 centimeters. So when we do this, we get that the volume is actually 4 times 3 is 12, 2 times 12 is 24 centimeters cube. So we can put this in our formula now. So we say that the mass is given us 214 grams. So we say 214 grams divided by 24 centimeters cube. So when we divide these two, we get that the density is 8.92 grams per centimeters cube. So we can use that in our formula now, and we'll say that the density of the substance is 8.92 grams per centimeters cube divided by the density of water, which is again 1 gram per centimeters cube. So when we do this calculation, we'll get that the relative density of the metal block, this metal block here, is equal to 8.92. And again, we have no units. Alright, so let's just do a quick recap of what we have learned so far. So we learned that the relative density of a substance is the ratio of the density of that substance to the density of water, which is our standard. Right, and again, the density of water is 1 gram per centimeters cube, or 1000 kilograms per meter cube. And again, the relative density is also a dimensionless quantity. It's a dimensionless quantity, and it has no units. The formula for relative density is given as relative density is equal to the density of the substance divided by the density of water. So again, this was Junior Roberts coming to you with realjuniorroberts.com. This was a quick introductory video to the concepts in physics. If this was helpful, please consider sharing, hitting the like button, post your questions or comments below, and thanks for watching.